Hello, if this is your first time visiting or listening, my name is Ann Spencer and I'm a product person. In a prior life, I was the data editor at O'Reilly Media, and it was there I had the opportunity and honor of meeting Pete Warden and being his editor at that time. And over the years, we've had so many conversations about industry and what's going on, and I've always appreciated the insights that Pete provides. And we recently decided to record some of our chats.
Yeah, and I'm Pete Warden. I like to say that I was doing AI since before it worked, formerly of the TensorFlow team. And I've been working with Anne on and off for years, always enjoyed talking to her about things, and thought this was a great way to share some of that.
I definitely appreciate it. I definitely appreciate it. So, for people who are relatively new to this series, in prior episodes, Pete and I have been discussing voice interfaces. And one of the things that he put out into the universe was he wished that more people would consider developing capabilities for voice interfaces. And I feel over the past few weeks that the universe responded right with various developments and announcements on voice interfaces. And Pete just recently released ONNX Shrink Ray, which has the potential to ease development for automatic speech recognition on resource constrained devices. Now, if people aren't familiar with ONNX, right, ONNX stands for Open Neural Network Exchange, and it is an open standard, right, for machine learning interoperability. Now, Pete's ONNX Shrink Ray, as the name suggests, right, helps shrink model sizes with minimal impact on model accuracy. So that's what we're going to be talking about today, right? So now we're going to move to some of my questions because I always have questions, right? So I was pretty excited to see that you released this, and I definitely see how it can ease development, for voice interfaces. I also saw on the GitHub when I was kind of going through the artifacts, I saw on the GitHub that you mentioned that you worked on this initially for Moonshine, right? So can you unpack for me and for people listening, like your process of why you decided to play with ONNX and why you decided to take this route for Moonshine? And the reason why I'm asking is that if I'm putting on like my product hat, or if I'm putting on like an external hat of people looking at this and listening and reading about this, it may help them when they're thinking about their own use cases, right, for voice interfaces. So if you could unpack that a little bit, that'd be great. I also noticed that you've listed things on the Moonshine GitHub, right, about the Moonshine ONNX model. So if you could help provide that context, I think that would be really helpful for people.
Yeah, definitely. And the key motivation was initialization speed, startup speed. The larger a model is, especially on the web, the longer it will be before somebody can actually start talking and using the model um, after the web page loads. So we focused a lot on really low latency for responsiveness, but startup latency really matters too. Um, and so a big part of that is just, hey, how can we make the model files smaller? Started
Mm-hmm.
off being, you know, 250 megabytes, 500 megabytes. That's a big download.
For sure. For sure. And I know that you touched upon this on the blog post and you actually have more specifics in the GitHub page, but I think for people listening that haven't had a chance to read it yet. So how does shrink rate work, right? Like I think that will help people in case they haven't seen this stuff yet.
So almost the entirety of model files are the weights of the neural network. That's what you get out of the training process. There's a little bit about the structure or the architecture of the model, but 99.9% of the file size is just these big arrays of numbers. And by default, they're 32-bit floating point. So that means 4 bytes per parameter. So if you have, a 30 million parameter model, you're looking at 120 megabytes. Um, and one of the kind of amazing things about neural networks is you can actually do a lot of the work in much lower precision. And it turns out that you can actually use effectively a compression scheme where you say, okay, we're going to look at each chunk of values, like each set of weights, which might be, hundreds of thousands or a million weights, look at what the min and the max of those are, and then just say, okay, we're going to store them in the max, and then we're going to have a byte for each value, which is the nearest point on that scale to what the actual weight is. And so you're really decimating the precision,
Mm-hmm.
but it turns out it almost never matters. You don't need 32 bits. You don't need 4 bytes. You can get away with 8 bits to store each value, and that almost doesn't change the results of the network.
Yeah, I love that. And thank you for summarizing the aspects that you cover in your blog post on the GitHub page. Definitely appreciate that. So let's talk about use cases. I will own that I want to talk about the browser use case because I was excited about that when you first mentioned it so long ago.
Yes.
I am that person. I think I've also mentioned this on prior episodes that I'm that person that has the captions on the YouTube videos all the time. And I know I'm not the only one. And if you don't do this, people listening, there are obviously a lot of people that are aware that people do this because that Vox video about people using subtitle on videos has over 14 million views, right? So definitely there's awareness of people doing this, but I would like to hear about how the team decided upon this particular use case, other than me being excited. That's my bias, right? But I would love to hear like why the team decided upon that use case, right?
So there are a lot of use cases with voice interfaces where you have to build out a whole bunch of things to make it useful. Like if you want to be able to, control a lamp with your voice, you kind of have to build like a lamp and, physically, and you have to get it into people's hands. And, it's a very hard thing to actually show why low latency voice matters.
Mm-hmm. Yeah.
On the web, especially with captions, I watch YouTube often with captions on for all sorts of reasons. And what we realized was this is a way of adding captions to any content on a web page that has audio. So you don't need to be YouTube and kind of go ahead and do something offline to get closed captions. We're setting things up so you can add a single script tag to your page. And we're also looking at doing a Chrome extension that does the same thing, that takes whatever audio is playing on the page and adds captions for you. So whether you're in a meeting, a video meeting with a service that doesn't automatically have captions, or you're watching videos or listening to audio on a page and you want captions for whatever it is, this is a nice way of actually delivering that.
I totally love that. I totally love that. So, what about other use cases? I know that you always hope that this will help bring people in, right, to develop their own and see what they develop with it. So, what are you hoping folks will deploy with ONNX Shrink Ray, right? What are you hoping, or what are you hoping to see, right? I'm asking because apparently the universe is listening to you right now when you put out the request. so now's the time to keep doing it, keep putting it out there, right?
Yeah, I think that what I'm looking forward to seeing is more stuff up on the web that's using all of these models that are already out there. We've got everything from, large language models doing all of these incredible sort of question answering type things to computer vision to audio. And this is one of the big practical problems with deploying at the moment is if you have a gigabyte size model file, you're not going to want to download that every time. But if you can get it down to 250 megabytes, maybe that's a little bit more practical. So I did actually want to ask you one question too, Anne.
Oh, cool! Because we're almost at time, so now's the time to ask.
Right? Yes. So what were your takeaways?
I think that I actually had quite a few, right? Because my brain was processing as I was reading through the blog posts and the artifacts. I think obviously right away was I'm excited about what people are going to do with the captions, right? Because you already know that about, we've talked about this before. I was like, oh yes, yay. So excited to see what's going to happen with that. Second, I think was how much I appreciate your approach to stuff, especially in the blog post where it goes just beyond research, right? There's the practical aspects of it, right? I think obviously my career has benefited from research and bringing research products to market and monetizing research. So I will own that I appreciate research deeply. But there's also this option of, or this capability we have to think about is moving things from research to production, right? And what I appreciate not only in this blog post, but in some of your other blog posts is that you think about that and you provide tools for that, right? And that in the blog post, there was the model savings download calculator, right? Which I think is really helpful when you're having a lot of internal conversations about capabilities, right? And the ease of developing it and when you are thinking about moving from research to production, right? And I very much appreciate that. I also think about, particularly for me, it was on the GitHub page, right? When you kind of walk through the pros, but you also are really transparent and open about, some of the trade-offs that you had to do, right? And I deeply appreciate that because when I'm making an assessment, that's something I think about. It doesn't like block me from moving forward, but it's something I think I should consider. And I think in this space, that sort of openness is what we really need right now, especially when we're building out capabilities and products that are really truly intended to be helpful for people, right? So definitely appreciate that. I think something that stuck out to me yesterday, so after you wrote and published everything, because I attended the Berkeley Law event about CEOs, right? And it was about, you got a lot of lawyers for just saying how it is, right? And a few of the panelists had a lot of really interesting insights about CEOs and whatnot. And some of the things that they talked about was they recommend that CEOs have legitimate empathy, right? And just be a real person. And I think that really stuck out to me because obviously I'm working with you on some stuff, right? And I thought about the holistic approach that you have, right? Um, and I remember thinking, I'm glad that Pete exists, right?
Oh,
So that's that's like the most recent thing because of everything that's going on and stuff like that.
no, thank you. That's very kind, and it's a lot to live up to. I mean, I've as CEO, I've had to fire people,
Mm-hmm.
and it there are at the end of the day, decisions come up to you when nobody else can actually figure out what to do, and
Yeah.
sometimes it's really tough. And I'm human; I'm going to make mistakes, but yeah, I hope that at least by being transparent and trying, uh, we it doesn't have to be as evil a position as as it sometimes seemed to be. That's my hope. I mean, come see me in a few years as I'm Mr. Burns sitting in my, unleashing the hounds on the peasants. We'll talk then.
I appreciate that because that's something that the lawyers on the panel were talking about is about CEOs are becoming more societal leaders, right? Not just heads of businesses. And it's a tough position to be in, right? That's a lot of pressure, right? But on that note, we are at time. I appreciate the time. I appreciate the transparency and all the contextual insights. I know I'm not the only one, as we found out recently with some of the feedback on our last episode. So I know I'm not the only one that appreciates this, right? So thank you again, and I'll see you soon on the next time. Right?
Awesome.
Okay.
Thanks so much, Anne.